My name is Tyrone.
And I'm Infiniti. Alors, we are starting with our concavity problem. First, this is Infiniti and Tyrone. Infiniti is reading, Tyrone is explaining the second derivative. Consider a differentiable function, f of x, with the given first derivative, find the x coordinates of any inflection point, and take the interval on which f is concave up or concave down.
Okay, so here was the first derivative. It was 2x squared, x minus 2 squared. Okay. I put that we had a product rule right here, and we had a chain rule just right there. Okay. Then I went to the side, and I labeled my part. F of x was 2x squared, g of x was x minus 2 squared, f prime x was 4x squared because 2 times 2 was 4. And you just got that 2 minus 1 was just 1, so just put 4. Then you have g prime, which was our chain rule, and that we had to use the u times the u prime. That was our u, and then the u prime comes from the derivative, which was just 2, and you don't write the 1. So now we're just gonna put all this together with our little formula, which is f prime x, g of x, plus f of x, g prime x. Okay, because f prime was 4x, g of x was x minus 2 squared, plus f of x, which was just 2x squared, times 2x minus 2. Okay, we can go ahead and combine that right here, make that 4x squared. Bring that down. Bring this down over here as well. 4x, x minus 2 squared. Okay. Next, we're just going to take out the smallest one in each of both sides. Okay, we have a 4x. Okay. We can also take out an x minus 2. Okay. Then what's left is going to go on brackets. We have an x minus 2 left over from here. And we have an x from that x squared. So add. Now we're just going to combine what's in here in the bracket. So that's going to be 2x minus 2. This is going to be, just bring it down. 4x, x minus 2. Now you have everything. You can just set everything else. All this equal to 0. That. 4x equals 0. Divide by 4. Divide by 4. X equals 0. X minus 2 equals 0. Add 2. Add 2. X equals 2. 2x minus 2 equals 0. So 2x equals 2. Divide by 2. Divide by 2. X equals 1. So you have your critical points, which is 0, 1, and 2.
Okay, now we got our critical numbers, 0, 1, and 2. We put it on a number line. These are our critical numbers, and these are the numbers we're going to test. The test numbers go in the second derivative, which is right here. We put that in the calculator. Oh, I need it. X minus 2 squared plus 4x squared x minus 2. Second window, and you type in your test numbers. -1 is first, and we get a negative number, so we put our negatives right here. Alright. Next, we're going to do 0.5. That's a positive number. Put our positive signs here. And next is 1.5. That's a negative number. Put our negative. And next is 3. And that's a positive number. Put our positive. And now we have to label concave up and concave down. This is negative, so it's going to be concave down. This is positive, so it's concave up. Negative, so we got concave down. Positive, concave up. Now I'm going to do my intervals. We have to do concave up first, and the concave up is from 0 to 1 because it's positive right here. So we got 0 and 1, and then we write x is greater than 0, but less than a positive infinity. And then we have 2 and a positive infinity, 2 and a positive infinity, so this is where positive signs are. So we write x is greater than 2, but less than a positive infinity. Now we're going to do concave down, and it's from negative infinity to 0, negative infinity to 0. And we write x is greater than a negative infinity, but less than a positive infinity. And then we do 1 and 2. And then we write x is greater than 1, but less than 2. And now we do our points of inflection. We have, x equals 0 because it went from negative to positive at 0. And then we have x equals 1, went from positive to negative at 1, and then we have x equals 2 because it went from negative to positive at 2. And those are points of inflection. They gave us the first derivative, and then we got the second one. We got our critical points right here. Then we came over here, and we put our critical numbers on a number line. So we found our concave up, got our intervals, got our concave down, got our intervals, and we found our points of inflection. And that's it. Boom. My position function for my velocity problem is dx equals 3x cubed plus 4x squared. When finding the velocity, you just find the first derivative. To find the first derivative, you multiply the exponent by the coefficient and then subtract the exponent by 1. My velocity equation is 9x squared plus 8x. When finding the acceleration, you just do the second derivative of the position function, or just find the derivative of the velocity. Part C. Find the velocity and the position of the particle when the acceleration is 2. You just set the acceleration equal to 2 and solve for x. Get x is equal to negative 1/3. Then you take negative 1/3 and plug it into the velocity function and the position function. X is equal to negative 5/3. X is equal to 1/3. Now, when solving the velocity problem, you just take the position function, find the first derivative to find velocity, take the velocity function, and find the derivative of that to find the acceleration. And then when finding the position of a particle when the acceleration is 2, you set the acceleration equal to 2, then plug in your x to the velocity and the position function to find the answer. Hello, this is See, right here we about done. All we gotta do is set these three things equal to 0 for x. For x equals 0, sorry.
Say goodbye. I hope all of y'all out there that listening to this, if you just have to say goodbye, I know it's so hard, but whatever right time, say goodbye. Love y'all, all my fans.